some steps, okay? And I'm going to make these as brief as I can, and then we're going to do some examples where you will discover how to do this, and I'll do enough examples that you will have, you know, kind of the flavor of where it all goes. So the first requirement is if the degree of the numerator actually, I'm debating whether I want to include this first step that I didn't include. I kind of go back and forth on how to teach this just because people get confused by it. No, we can use that wording. All right, if the degree of the numerator is greater than or equal to the degree of the denominator, comma, divide first. And I will do an example once we get through these steps. I just want you to have these steps in your notes, and then we'll do an example of each possibility that's addressed by these steps, okay? So that's the first thing you have to look for. If it's top-heavy or equal degree, matching degree, then you're going to divide first. All right? Step 2 says to factor, and it's not really step 2, and you'll understand this after we do examples. It's hard to explain. Factor the denominator and I'm paraphrasing, so I'm trying to decide how much of this I want to put in here in detail, into linear or non-reducible quadratic factors. It's actually irreducible, but we'll go with non. So in other words, I'm going to factor anything I can out, and then non-reducible or irreducible quadratic factors are quadratic factors that can't be factored into linear factors. Does that make sense? All right. And then sometimes what will happen is you'll end up with a factor that's like x plus 2 to the second, the quantity. You know what I'm saying? Okay. All right. And I'm going to show you this case, which looks kind of scary. And so we're going to write, and I'm paraphrasing into the method. I'm going to show you the way to understand this, because even if I made the copy of what's in this pre-cal book, I think it might just be more confusing than it is helpful. So we're going to write, and that's W-R-I-T-E, which matters because what we're about to say is the right, R-I-G-H-T. Write the right side. And I'm going to put a colon and then just going to write this symbolically. And this won't make a whole lot of sense right now, but it will make more sense shortly. All right, so A sub 1 is capital A sub 1 is your numerator, and we do use capital letters for the numerators in this system of processing these guys. All right, over mx plus n. Plus A sub 2 over mx plus n, the quantity squared, plus dot 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 plus A sub n over, oh, we can't use n because we got n in the denominator. Sorry about that. a sub u is what they're using in this book, so we'll go with that. Mx plus n, the quantity, to the u power. All right, so a couple things to notice about what we've just written. And if we notice it now while we're writing the steps, when we start doing the examples, you won't be like, why are we doing that, okay? So here's basically what this rule tells you. And I'm going to say it, and then you can write down anything I say that makes this click a little bit. And if it doesn't click, don't worry. Hopefully it will in the examples. All right, so first of all, what do you notice about the denominators of all three terms we wrote? The mx plus n they have in common, right? Which would be a linear factor, yes, because there's no exponent in it. All right, but what you do is when you do step 2, where you factor the denominator, if you have an let's say you had 3x plus 4, the quantity squared, then your first fraction would be a sub 1 over mx plus n. All right, because I could write that first term as a sub 1 over mx plus n to the 1 power, right? Okay, so I write a linear version, and then I do plus a sub 2, and these numerators are all constants, and we're gonna learn how to find those today. All right, a sub 2 would then be over 3x plus 4 squared, and that's all I would have for that one. All right, well in this example it goes to the nth or the u possibility. All right, so as you could have, there's no limit on how many you can have. You won't have one with scary numbers, so don't panic. But basically, you write however many terms you need. So if it's a cubic factor, or factor cubed, then I have to have a cube term, a square term, and a linear term. If it's a square term, I have to have a linear term and a square term. If it was a fourth degree term, I would have to have a linear, a square, a cube, and a fourth power term. Does that make sense? Mm-hmm. So that's what we call a repeated factor, okay? And that happens anytime you have something like x plus 2 to the second or third in your factorization of what you factored. Does that make sense? So if you need to make a note there, you can. If you can wait and see if you need it from the examples, that's fine either way. All right. And then, and like I said, I debate about writing these steps just because they look kind of scary, but I feel like if I don't give them to you, you're going to get stuck when you try these on your own. And the good news is that today's assignment is really short because it's just you practicing just this skill before we learn the calculus of it. Like I said, the calculus is going to be stupid easy after you've done this part. And this is not super hard, it's just something you hadn't done before. All right, well, let's just say instead of mx plus n, which we agreed is a what kind of factor? So you might want to jot that out to the side somewhere. Those were linear factors. Well, we're going to look at the irreducible quadratic possibility. Okay? So, and I don't really like the hideous version they used, but I'm going to run with it. All right? So for each factor, and then we're going to have, and I'm going to use the same letters they do just so I don't cross myself up. Okay, well that's simple enough. Inside the parentheses we have ax squared plus bx plus c. So I have some quadratic thing, right? And then we use the variable v here for our exponent to the v power. All right, now I'm going to write this and then we're going to compare just the first term to the first term of the last one we wrote, okay? So the denominator of the last one we wrote was what kind of factor? Linear. And the numerator is a what? Constant, okay? Store that away and we'll come back to it, okay? So your first term here is going to look somewhat the same. All right, so then we're going to start off with bx plus c as our numerator, which is, how would you classify that? Linear. Over ax squared, wait, I don't need the parentheses on the first one. Ax squared plus bx plus c in the denominator. Compare that term to the first term in the previous step.
The numerator's linear in this one, not a constant.
Okay, well in the first one we had a linear denominator and a constant numerator, right? Mm-hmm. Here we have a quadratic denominator and a linear numerator. So what's the relationship?
Kind of like the first one we had the derivative.
The numerator is is 1 less in degree, right? So if the bottom is degree 1, the top is degree 0, because all constants are degree 0. Can we agree to that? Okay? And in this case, my denominator is degree 2, and my top is degree 1, right? So you're always going to, if it's quadratic, you have to have a linear factor. If it's linear, you're going to have a constant factor as your numerator. Does that make sense? All right. Well, the pattern after that first term is going to follow, okay? So then we're going to have a, and I think they actually use 1 subscripts here, but I'm going to use, we'll just jump over here and do this as a b sub 2. b sub 2 x plus c, so 2, over, what do you think my denominator is going to be? That's right, the same quantity squared. So it's going to be ax squared plus bx plus c squared. And then I'm going to put plus and then 3 ellipses, or 4, however many this pen decides to make. And then I'm going to write this other term underneath here, but I would write it to the right if I had room. So then my next term, or my final term, is going to be b sub v x plus c sub v over the quantity raised to what power? There you go. You're getting the pattern. And that's what I want you to see, not a 2. I just want you to see the pattern in these steps before we start. Now, that's kind of a generic breakdown of how this process works, but now we're going to actually do a couple to see what we get and how this actually works in terms of actually doing an example. Hi. Miss me? I don't know what that was. Okay. Apparently I'm not the only one who struggles with mornings, huh? All right. The first couple we're going to do, and this is out of your pre-cal book, so y'all don't even have these. So the first couple you're going to do as examples, we're not actually doing a partial fraction decomposition. We're just practicing what they're telling us to do, okay? But this is also going to be this is where, to me, the real steps come from in your head, all right? So I'm going to ask you what we're doing. All right, so first of all, I have x squared minus 7 over x times x squared minus 4. And the directions say, write the terms for the partial fraction decomposition of the irrational function. Do not solve for the constants. So basically, they're going to just have you set this one up and not actually do it, okay? And then we're going to do one where they give us the setup and then we do it, and then we're going to actually do a whole one all by ourselves, okay? So, if we look at the very first step, what did it tell us we need to do? Yeah, you got to check your degrees, all right? Because if what's true, what do I have to do? Right, if the degree of the top is larger than the degree of the bottom, I have to divide first. Do I need to do that here? No, because the top is degree 2, the bottom is degree 3. All right? So then, your actual step here is to factor the denominator, which we actually had as number 2 on that list I just gave you. And you'll understand that list probably seems kind of weird even when we start doing the examples, but as you go through and start having to think about how to do them, hopefully it'll make you understand why we did it that way. All right, so we have to factor the denominator, and this denominator is not completely factored, is it? They have taken the liberty of pulling out an x for some reason and left the rest for us to do. So what is this denominator factored? X plus 2, x minus 2. Doesn't matter what order you write them in. And here's your partial fraction decomposition. This is how it works. Okay. Now, what we did in the previous one might have seemed like that was the whole story, but that was just term by term, okay, or factor by factor. All right. So what we're going to be doing is we're going to be setting up equations like we're about to write, and then we're going to figure out what the numerators have to be, and then we're going to integrate when we start doing the calculus tomorrow. You with me? Okay. So our first term we're going to call the numerator capital A. Why do I know I only need a constant numerator? Because all the factors in this denominator are linear. All right, so I put a over x plus capital B over x plus 2 plus capital C over x minus 2. And my work according to those directions is done. Do you understand what we just did?
Oh, okay.
Okay.
Because we separated them all into linears, and then.
Yeah, you factored the denominator. So basically, what did we just do? Let's recap it. We factored the denominator into linear factors, because that one step that we wrote on that first set of stuff we wrote down said that we need to factor the denominator into what? Linear factors or non-reducible quadratics. We didn't have any quadratics here that couldn't be reduced, right? So we reduced the quadratic into two linear factors. Does that make sense? All right, so then you set up a term relative to each one. Well, let me show you where all this comes from, and then you'll understand what this seemingly abstract thing we're doing is, okay? All right, let's just take a little sidestep here. And we'll put ellipses here, like, because I can imagine in your head, you're like, what in the name of holy are we doing, right? Well, I'm going to show you, all right? If I had to add 1/2 plus 2/3, what would I do? I would have to have common denominators or use some technique for getting that done, right? Okay? Well, feel free to grab a calculator so that we can speed things along, or Richard can do this in his head, I'm sure. What is the sum of these two fractions? 7/6?
5/6.
Okay, well, how many 6s in 1/2? 3. How many 6s in 2/3? 4. 7/6. Don's like, yes. Did you relay Richard's answer, or was that all you? Oh, Richard, you're letting me down. My human. What'd you say? Of course you did. Okay, so here we go. Well, so basically it's like this. It's like somebody handed us 7/6 and said, decompose this into where it came from. Right? So write a sum of two fractions that would give you 7/6. Well, how could you do that? Well, first you could rewrite 7/6 as 2/3. I'm sorry, over 2 times 3. Couldn't I? Because I haven't changed anything. Well, then that would tell me that I added something over 2 to something over 3. There's your epiphany you needed, right? So you feel like you understand what's happening? Instead of feeling like you came inside from the fog and then back into the fog, right? Come on, people, work with me here. I'm struggling up here, man. We did 2 consecutive actual days. Maybe that's why Wednesday's so hard, right?
It's
Yeah.
like, when you swim and then you're like in the middle of the pool. That's what I feel like right now. I'm almost to the end, but I'm not to the end yet.
Twitty, have you ever heard this super funny story of Marquise swimming in the pool one day?
Mm.
Oh,
No.
can he please tell you? It'll make you laugh so hard.
It will.
It will.
Okay, better question. Did you hear what Becca just said? Did you drown? Okay, go ahead. Let's go. Do it really fast. And Maury's like, could y'all please stop running your mouths and let's do this? So I'm watching this video right now.
Okay, so I was in the pool and we were in California because we were doing something for band, right? And so we were all in the pool.
Wait a minute, rewind. You were in California because you were doing something for the band?
Yeah, we were doing something. We were like going to see a concert or something.
Who's we?
It was 9th grade. I know that for sure.
In the 9th grade, the band went to California?
I'm not sure if it's California or Florida.
The location is irrelevant.
Okay, I'm sorry. It just threw me that he said he was with the band. Okay, I'm going to pause the video. I'm sorry, Morgan. You'll have to ask me. Marquise, you're missing the point. Stop talking to me. Okay. Here's example. This is really, and I'm going to call these examples, but they're not technically examples. I'll let you know when we actually do a whole example here in just a minute. But we have x plus 22 over, and they have saved us the trouble of factoring this one, x plus 4, the quantity, times the quantity, x minus 2. And they also set up the right side, like we don't know any better, capital A over x plus 4 plus capital B over x minus 2. And I'm going to fix that second 2 because it looks suspect. Like, is that actually a 2 or is that a square? X plus 22 is your numerator. All right, you ready? Okay, so we're going to, now, and you don't care what this says because it's not your book. We're not going to use a particular technique. Our job is to find A and B. Okay, I'm going to show you one technique for this. So you need to make sure you get it. You ready? Okay, if I want to know what A and B are, the first thing I'm going to do is to get X plus 22 by itself. How would I do that? Because this, what we're about to get when we do that is called the general, or we'll call it the general equation, okay? All right, so if I multiplied both sides by the denominator of the left, I would be left with, and in fact, I guess I should write that out. Let me do that. And I'm going to erase my example 2 notation. You don't have to. And I'm going to switch colors here to a green color because we're going to multiply each side. That way you'll know what we did. X plus 4 times x minus 2. So write that out on both sides. And then we're going to if we do that on the left, we have to do it on the right. So we're going to multiply by x plus 4 times x minus 2. Now, you don't have any reason to know why we're doing that. Just trust me for a minute, and then the reason we did that will become apparent momentarily. All right? So, and then I will talk you through the full step process when we do one from start by ourselves. Okay? All right, so when we do that on the left, what are we going to be left with? X plus 22 equals. So the left side looks better, right? Okay, well, if I multiply A over x plus 4 times x plus 4 times x minus 2, what's left? A times x minus 2, because the x plus 4s go away, right? Plus, and then B times x plus 4, right? Because the x minus 2s would go away. That is our general equation, so put a box around it. That was the objective of what we just did, was to attain that general equation. Okay? You're probably going to run into one on your assignment tonight, and you must have this done when you get back tomorrow or you will be lost. You're probably going to run into one or two where they throw some curveballs at you, and if they do, we'll address that before we go over the calculus, because the calculus is much easier than this is, actually. All right, but here's your strategy, okay? You're going to start by letting x be 2. Now, I'm not going to tell you why I'm doing that, but I want you to look at the equation and tell me why I'm doing that. If I let x be 2, what's about to happen? Okay, what disappears? The a. All right, so if we let x be 2, on the left side we have 2 plus 22. And if I have a times 0, and I'm going to put that there for emphasis. That's not a of 0, that's a times 0. Plus, what's 2 plus 4? So 6b. Right? Which gives me 24 equals 6b, which means that b has to be what? 4. Got one of them, right? All right, and then if I let, on my first choice, I let x be 2, what would be a good choice for my second one? Negative 4. All right, so now I'm going to have negative 4 plus 22 equals, is the a going to go away this time? No. So when I put negative 4 into x minus 2, what do I have? Negative 6. So this is negative 6a. And what's going to happen to my x plus 4? So we could write that as 0b. Be another way to write it, right? Y'all with me? Okay. So negative 4 plus 22 gives me 18 equals negative 6a, which means that a has to be what? A equals negative 3. So then our answer to this problem is negative 3 over x plus 4 minus, oh no, sorry, plus 6 over, no, 4, my bad. I don't know why I had 6 on the brain. 4 over, what was the other factor? Believe it or not, I can't see it on the screen where I'm writing it. So this is the answer. So that, in the what we arrived at for our answer is the partial fraction decomposition of the left side of the original statement we were given, which is x plus 2 over those two factors. Does that make sense? Let's do another. What, is this example 3? Okay. I'm still playing that video of the pool in my head, so I'm having a hard time focusing. Okay, we have x squared minus 2x plus 1 as our numerator over x minus 2 cubed. And I want you to tell me what our right side would be. Well, first of all, what kind of numerators are we going to need and why? Okay, what is the factor in the bottom?
X minus 2.
The factor is x minus 2, right? Which is linear. So that means my numerator is going to be a constant. All right, so I'm going to put a over x minus 2. Thank you. Plus b over x minus 2 squared plus c over x minus 2 cubed. This is one of those with a repeated factor. So this is how you handle repeated factors. Okay? Because your numerator is always going to be 1 degree less than the factor of the denominator. Not then the denominator, but the factor of the denominator. Does that make sense? Okay. So we play the same game. Well, what would I multiply by to get rid of the denominator on the left? Okay. Well, I'm going to see if I can't write this without erasing my example number here. I'm going to multiply through by x minus 2 cubed. So if I do that on that side, I have to do it on the right side. And when I do, I get x squared minus 2x plus 1 equals, all right?
X minus 2 squared.
Right, so we're going to have a times x minus 2 squared plus
X minus 2.
b x minus 2 plus c. Y'all got it? That's our general equation. Put a box around it. Because notice once you get that, you don't do any more solving or isolating. You're just, that's what you're plugging back into as you choose your values. Okay? Now, what makes this one unique from the last one is that we don't have two different options. There's literally one option for letting things disappear. Right? Okay? So we're going to, what would be our choice here for that one thing? Let x equal 2. And then that gives us 2 squared minus 2 times 2 plus 1 equals C. Why does it equal C? Because you have a factor of x minus 2 attached to every constant, which means all those are going to disappear, right? All right, so then on the left, 2 squared is 4 minus 4 is 0 plus 1 is 1, which that tells me that's what my C value is. So we've got our C. Fair enough? So I already know that in my answer box, there's going to be a 1 in the numerator of the x minus 2 cubed. Got it? Okay. So then, and one of the reasons I wanted to do this example is, and I used to do like one big example that had a bunch of this going on, and people were like, what? So now I'm doing them in pieces where you can see all the little special things that can happen. All right, well, we've used up the only candidate to make things disappear, right? Okay, well, what is your favorite number? If I said you could plug any number you want to into something and get an answer. 0. So let's do that. All right, let's let x equal 0. Now the cool thing is, on these progressive ones like this, as you move down through these, you can also plug in the one you just found. So when we get to C, we're not going to write C, it's 1. You with me? All right, so we're going to go again. So we're going to, if I plug 0 into the left, what do I get? 1. So I get 1 equals, right, because all my x terms disappear. All right, and then if I plug 0 into x minus 2, I'm going to get negative 2, right? But then when I square that on the a, 4. So I have 4a plus, well actually, it's minus, right? Because when I plug 0 into that factor, I have negative 2a, so it's minus, I'm sorry, b, so it's minus 2b plus 1. Right? Okay? Well now, I've got an a and a b, but that's okay because I can establish a relationship between a and b here, can I? Alright, so the first thing I would do is subtract 1 from both sides, and I get 0 equals 4a minus 2b, which tells me that, in fact, now I'm going to, before I do the implies, I'm going to divide through by 2. Okay? So then I get 0 equals 2a minus b. So that tells me that b has to equal 2a, doesn't it? That make sense? All right. What is your, and I'm going to try something. I'm going to go to a new screen here, and y'all going to have to keep me posted on what we already did. You ready? Okay. What's your next favorite choice in numbers? 1. So let's go with 1. Let x equal 1. All right. So if I plug 1 into the left of that, what do I have? And I'll look back. We're going to have 1 minus 2 would be negative 1 plus 1 is 0, right? So that gives us 0 equals, and we are plugging 1 into x minus 2. Negative 1 squared is 1, so that gives me a, right? And then what happens when I plug it into x minus 2? So it's minus b plus 1. Right? Okay. So then I'm going to subtract the 1 over so that I have just a minus b together. And I can't establish a relationship here, but I just established a relationship from the previous one. What was the relationship from the previous one? B equals 2a. So I can, but I'm getting a on the brain here. I can replace b with 2a. It's a little system thrown in the middle of our partial fractions here. All right. So negative 1 equals negative a means that a equals 1. Right? So b equals 2. And we're ready to write our answer, aren't we? Y'all with me? All right. So we had a was over x minus 2. No, I don't need parentheses, right? Because that was the linear one. All right. So my a is 1. And my b is 2. So that's plus 2 over x minus 2 squared. Plus, and c was 1 also, wasn't it? So 1 over x minus 2 cubed. And that is my partial fraction decomposition of the left side that we started with. It gets easier as you do a few. All right, let's do this one. We're going to do one from scratch that's not quite as hard as that one was. But I wanted you to have that one just because a lot of times I don't get to one like that, and then y'all, the students that I've done that with in the past got confused. Example 4, yes? All right. Let's do 4 over x squared minus 1. And it's our job to write a partial fraction decomposition of this guy. Okay, so what's our first step? Factor the denominator. All right, if they hadn't done that for you, that's going to be your first step every time. So what's our factorization going to be?
X
Remember when y'all stared blankly at that at the beginning of pre-cal? Like, are we supposed to know how to do that? Yeah, from Algebra 1. All right, so what's my right side going to be?
A over X plus 1.
A over X plus 1 plus B
Over X minus 1.
over X minus 1. And then what are we going to do?
You're gonna plug in 1.
Nope, we ain't plugging nothing in yet. We got to get the numerator on the left by itself, right? So we're going to multiply through by the denominator, and let's see if we can go straight to our general equation. And how quickly you do this and how much work you write down is a very individual thing. Like, you write down what you need to write down to get these, okay? So we're going to multiply both sides by x plus 1 times x minus 1. And when I multiply a over x plus 1 times that product, what's left? A times x minus 1. And then I'm going to have plus b, and that is my general equation, so I put a box around it. And what's my first choice for assigning x? 1. Let x equal 1. So you're always going to start with the thing with a number that makes at least one of the factors 0. And in some cases, like the one we just did, it makes the factor 0. All right, and then when I let x equal 1, obviously 4 doesn't change, right? When you have a constant on the left side, there's nothing to plug in. You just plug in x wherever it is. If I plug in 1, what happens to my a? It goes away, right? So you don't even have to write that. If you want to write it, you can write that step. If you don't want to write it, which I'm not going to, you don't have to. So when I plug 1 into x minus 1, I get 0, so a is gone. And then what does that leave me? 2b. So what's b? b equals 2. All right, what's my next choice? Let x equal negative 1. And then again, we still have 4 on the left. And then when I plug in negative 1 into the a factor, I get what? Negative 2a. What happens to my b? It goes away. So we're left with a equals negative 2. And my partial fraction decomposition is negative 2 over
X plus 1 plus 2 over X minus 1.
Now, on this fairly simple one, and does that feel better? That's why I wanted to do a simple one. I thought this would be a good time to kind of lock in the process. Let me see if I can't help you see the whole point of all this. Why are we doing this? Well, and if that flow chart I gave you about how do we approach this integral, and for those of you that weren't here, don't leave without those. You start out with something like 4 over x squared minus 1. If I had to take the integral of that, if you go by that flow chart, the first thing you would hope for is a rule, right? Don't have a rule. Then you'd look for maybe a u sub, right? What's wrong with trying to do this as a u sub? If I did it as a u sub, what would my u be? X squared minus 1. But then I would need a du of 2x, right? I would need 2x that's not there. There's no x there to be my du, right? So u sub fails. And when it's not u sub, and clearly this is not a parts problem, right? Then this thing that we're learning today is your next step. Because now look at our decomposition that we've just arrived at. I have negative 2 over x plus 1 plus 2 over x minus 1. Now I'm going to integrate that, right? Because the integral of the original is the integral of that sum. You with me? So if I were going to integrate negative 2 over x plus 1, what would I do? Yeah, we're going to do it piece by piece, right? So we're going to pull that negative 2 out because it's a constant. And I have 1 over x plus 1, which is really a u sub, right? And my u would be x plus 1. Why does u sub work now when it didn't a minute ago? Because the du here would be dx, wouldn't it? Because it would just be 1. You with me? And you have the same thing going here, which is why you want linear factors. Does that make sense?
And we're doing the integration part tomorrow.
Yes. Yes. I didn't give y'all a ton of these to do. I just gave you enough for you to kind of get the idea, because you'll practice this approach when you start the calculus as well. I just didn't want you having to try to figure out how to do both at once. All right, let's do this one. Example 5. Do y'all see why we need tons of examples, though? Because you kind of put all the little pieces together. We have 1 over x squared plus 2x. What's the first step? Factor the bottom. So do that while you're in the mode of copying the problem down. And x squared plus 2x obviously factors into x times x plus 2, which would make my right side what? A over x plus b over x plus 2. Yes? All right. And then I'm going to multiply both sides by the denominator. And I'm going to get what? 1 equals a times x plus 2 plus bx. And that is my general equation, so I put a box around it so I'm not tempted to do anything else with it. What's my next step? All right, and it doesn't really matter which one you do first, and there's no right or wrong answer, but let's just go ahead and let x be 0. If you do the factors in order, you would do -2 first. It doesn't really matter. All right, but if I let x be 0, tell me what my equation is left with. 1 equals 2a, and the b's gone, right? So a is what? A is 1/2. And then we're going to let x be what? -2. And we get 1 equals -2b. B equals -1/2. So then our partial fraction decomposition. Now I'm going to write this 2 ways to help you see why you're going to, because you'll run into this when you start doing the homework and checking your answers in the back and whatnot. When you have a fraction, first of all, if you have a fraction, when you're doing it for the purpose of using it for calculus, that fraction becomes the constant you're going to pull off, right? So that would be my first piece of advice. But for that reason, and only for that reason, I would suggest that you should write it this way. And this is going to be awkward, and it's kind of not really legal, but since this is not, today it's part of your answer, but for where we're going, which is to apply the calculus to it, to me this will make it easier. All right, so my a was positive 1/2, right? So I'm going to put 1/2 over, and what was its factor? Oh, just x. Okay, let me center that x. All right, plus, or actually minus, right? 1/2 over x plus 2, right? And leave it like that. And that seems awkward, but if my next step is to take the integral, which is why you're going to be doing these partial fraction decompositions, then you would pull those halves out. And that way, because your other option, and I said I was going to show you both ways, and this would probably seem more natural. You're going to put 1 over 2, and you don't need a parenthesis for x. So 1 over 2x minus 1 over 2 times the quantity x plus 2. That would be the technically correct way to write it. But this first way is probably going to be more of what we need to think about in terms of pulling out the constant. Because the constant I would pull out of the first one is 1/2. The constant I would pull out of the second term is -1/2, right? You see what I'm saying? So just writing it that way might help you. Especially since y'all aren't great friends with fractions. All right, let's try one more, and this might just be our last one, and then I'll give you whatever time remains to start your assignment. But you want to make sure you have this done when you come to class tomorrow. In this example 6? Can't believe I'm keeping track of that. Normally I don't. But when you come to class tomorrow, you want to have these done. And of course, notwithstanding, there may be some that you got stuck on, and that's where we'll start tomorrow before we go into the calculus. But believe it or not, the notes for the calculus part will be like 1/4 the length of the notes for this. Okay, because it's so, and I kind of previewed that for you by explaining why we were doing this on that last one. All right, so we have 2x squared in the denominator plus 5x minus 3. You probably can't look at that bottom and factor it, I'm guessing. All right, so this is where you should be applying Twitty's method for factoring. And I call it my method not because I invented it, but because it's the one I proclaim as the easiest to remember and apply. All right, if I have a minus 3, that means we have a plus and a minus. We put a 2x in the first spot of each binomial as a little refresher on this factoring technique. And I need the factor pairs of 6, right? Because you multiply the coefficient by the constant with a difference of 5, right? So I'm going to put the 6 with the plus and the 1 with the minus. That means that 2x minus 1 is actually one of my factors, right? And I can pull out a 2 from the first one and be left with x plus 3, right? So now I'm ready to rewrite the original as x plus 17 over x plus 3 times 2x minus 1.
Let's do it. You know, I did that. I was at Upper Bound, and it's like we had this math teacher, and like I did it that way, and he like had a whole argument with me. He's like, "Where's the 2 go?" I'm like, I don't know.
Well, let me prepare you so that when you go to West Point and have that argument, you can actually have an answer.
Yeah.
Where did the 2 go? Well, where did the 2 come from is the first question. And that's how you should answer somebody. You should say, well, first of all, where did that 2 come from? I put it there. I know it doesn't belong there. How do I know it doesn't belong there? Because 2x times 2x is not 2x squared. Right? So I brought the 2 in. So if I brought it in to get the right answer, what do I have to do? Get it back out, right? There's your answer. Be my minions. You can't be my minion if your answer is, I don't know, I just do it.
But I argued him down though.
Oh, did you?
Doing it.
I may not know what I'm talking about.
Well, the methods people use for teaching kids how to factor blow my mind. The box method, I'm like, dear God, why did we come up with that? Because we hate children? Okay. Okay, so my generic decomposition is going to be a over x plus 3, b plus b over 2x minus 1, right? Okay, so here we go. We're going to multiply through by the common denominator and get x plus 17 equals.
A times 2x minus 1. plus
Matthew is all over this. Either that or he found Jesus last night and Jesus said to him, go to class and participate. Welcome. We've been wondering when you would get here. Plus, we the royal we. Okay. Plus b times what, Matthew?
x plus 3.
Yep. All right. There's my generic equation. Who wants to tell me the next step? Let x equal, and I don't know where the x went in that. Let's try that again. Let x equal 1/2. And some of you might be saying, do we have to let x be 1/2? We don't really have to let x be 1/2, do we? Yes, we do.
Why would you try and trick us?
That wasn't a trick.
It's really, yeah, I was like,
I just think it's cute how you're like, oh, 1/2. Like it's a nightmare or something. Okay, how many halves are in 1? So how many halves are in 17? So the left side is 35 halves. That was not difficult, was it? You too can do that. All right, what happens to the first thing when I make x 1/2? It's 0, right? Okay, and then over here, let's play the same game. How many halves are in 3? So that means I have 7 halves b. Yes? All right, well then that really means I'm dealing with 35 equals 7b, right? Because I can get rid of that denominator since it's the same on both sides. So what's b? B is 5. That wasn't too painful, was it? All right, what's my other let? -3. And then that gives me what on the left? 14 equals? Oh my God, what was that? I was expecting like a chorus of answers, and I'm like, oh. And all I ask you to do is plug -3 into 2x minus 1. I might give my 1Bs that as a warm-up this morning. All right, so if I plug -3 into x plus 3, what happens? B goes away, guys, because my coefficient is 0, right? Jeez, you're killing me. So what does this tell me? And y'all are losers? Did that hurt? Okay, so I'm going to put -2 over x plus 3 plus 5 over, and that's my partial fraction decomposition. That wasn't too horrible, was it?
it's not that bad now.
What if you get your like your A and your B
mix up. Like, what if I had a over 2x minus 1?
If you, okay, that's a good question. Did y'all hear what Haney was asking? He said, what happens if I get my A and my B mixed up? Well, when you write the right side as the generic decomposition you're shooting for, and then you come down here and you define the A and the B, if you write them in the wrong place, you've written the wrong answer. Right? Because you defined A to be the numerator of x plus 3. And you defined B to be the numerator of 2x minus 1. So it would technically be wrong. I mean, and if all I were grading was your ability to do partial fraction decomposition, my personal view is that that's a small error, but in the grand scheme of things, it's going to be. And you might wind up doing that while you're either doing tonight's assignment or while you're doing the actual calculus part tomorrow, because you're going to continue doing this once we get into the calculus. You're just going to tack on the calculus. But the great thing is, literally, you'll be able to look at your answer and write the integral. You won't even be doing steps for the calculus part. Yes?
Does it make a difference about, so say if our x plus 3 and our 2x minus 1 were flipped, and so we had a over 2x minus 1 and b over x plus 3, does that really?
Yeah, but see, if we had, okay, let's just say, and this is sort of an extension of Haney's question by Madison, if you didn't hear it. She said, well, what if I had put 2x minus 1 under A and x plus 3 under B? Well, then when I got down here, A would have been 5 and B would have been negative 2, right? Because it's contextual to how you defined the right side,
Okay.
right?
So,
So if y'all are working together and say Madison writes what we wrote and Brandy writes the other way around, so she writes A over 2x minus 1 and B over x plus 3, then their A's and B's are going to be backwards because they're going to end up with the same final answer. Do you see what I'm saying? Okay. Excellent questions.